Hi everyone, Srini here. Welcome back to my channel. So if you are new to this channel, please do subscribe to it and hit the bell icon to get notifications. So you will be getting a lot of useful videos in your professional career, be it in terms of technology or any languages and any particular tool, automation tool which you're interested to learn. You're going to get a lot of useful content in this particular channel. I promise you that. And today I'm going to come up with another important and useful topic for anyone who's preparing for interviews or who is ready to learn a particular programming language from scratch. This particular video is definitely going to help you all because I'm going to put my entire efforts to ensure you learn it from scratch as well as you learn it just within 1 hour. Right, that's right. So today's topic is about learning Java in just 1 hour. I know it's very difficult because you cannot completely know end to end as a professional in Java in 1 hour. So what we are going to do in this particular 1 hour session is going to that we are going to learn from basic installation to learning Java, practicing it, as well as knowing all the important concepts which you need to know when you go for any interview or when you want to revise one day before your interview, like a last day revision. So this 1 hour of video is going to help you all to just quickly revise all the concepts and just go prepared for the interview. That's what is my goal here. So let's get started on the same topic. So this will be our today's coverage. We're going to look at quick introduction to Java language. What are the different Java features? What are the applications using Java? Then we are going to deep dive into the Java core fundamental concepts, which you need to definitely know if you're going to prepare for an interview. Then we are going to go into Java oops concepts, right? And then we have Java exception handling, and then the totally important topic when you are preparing for any interview or any exam or any practical exam, that is Java collections. Okay. And in case if I get time, I'll also cover a separate video where I'm going to talk about Java 1.8 features with detailed examples that we're going to look at as a part two. Okay. So let's get started. So Java is an object-oriented programming language, and it is used to build secure applications. So it is basically built with security as a kind of a thing in background that we need to have a secure applications using Java. It's also used as a platform. So you might get confused and someone says it's a language or is it a platform? It is both. Okay. What are the features of Java? It is simple programming language to understand. It is object oriented. What is object oriented? We'll deep dive into that. Don't worry. It is portable. That means you can write a code in your particular OS or operating system and you can have it work somewhere else. So it's a very useful feature. It is secure. It is platform independent in a sense that you can run it in any operating system. It is not dependent on any particular OS. It's robust. So its integrity is very much guaranteed. It's very difficult to break the integrity of the code which you have written. That is why it's robust. It's interpreted as well. What we mean by that, you will definitely come to know in another slide. Then what is multi-threading? Multi-threading basically gives you a way of doing execution across multiple threads in parallel. So that way it gives you high performance. Okay. So these are the key important features of Java. What are the applications today which uses Java? We have different desktop applications which are built using Java language. It is also used for development of different websites, right? And also we have seen in different games as well, Java is a popular language. It is also used for certain apps creation, which is present in the Play Store, okay, for mobile apps. That is all we have from a presentation perspective. Now let's get directly onto the practical part. So what I would be doing is I'll be trying to show you all. So I'll just show you all download Java, right? So download Java 1.8 for Windows, okay, 64-bit. Okay. So what we'll be doing is we'll be downloading Java from this website. So go to this archive downloads. Okay. And you can see we have Java 8 version present. So we need to download Java JDK 1.8. Okay. So JDK 1.8 is present here. So click on this one. Okay. It will ask you for accepting terms and conditions. Accept that and click on download. Okay. Now what it would do is it is going to ask you to sign in into Oracle website. Okay. So it will ask you to sign in into your Oracle account. If you don't have an Oracle account, you will have to just click on create account and do a sign up. And once you have signed in, you will be able to download the JDK link. So once it is installed, I'll just quickly show you all how it's going to be seen. Okay. So you can go to your C drive, okay, program files. Once it is installed successfully, you can go to your program files. There will be a folder created called Java. Open it, and you can see there will be two folders created: JDK 1.8 and JRE 1.8. Okay. And once these are created, what you have to do is you have to go to your computer, this PC, right click on it, do properties. You have to set basically two variables, path and class path. So that's what I'm going to show. Go to advanced system settings, go to environment variables, and here you can see that I have a class path till JDK lib, and you also need to create couple of more things. So you need to set up a Java home variable with JDK 1.8 path. So within Java, you have a JDK 1.8, so that will be your Java home. And you need to also edit your existing system variables path variable to include Java. So I'll show you where it is. So if you see here, I have a variable which is having the value till bin folder within JDK 1.8. So how do you edit the value of path to add any new value? You simply have to put a semicolon like this. You have to put a semicolon and then copy the path of your JDK till bin folder. And for class path, you have to go to the path till lib folder, lib folder. So that way your compiler knows where exactly to search for the libraries or where exactly the compiler options are present. Whatever libs are present, right? Whatever supporting libraries are present, that the compiler would be able to figure out. Okay. So without any further delay, let's start with our first program. Okay. This is all what you need from a Java perspective for it to be set up. You need to download Java 1.8. And after that, what we need to do is you need to also install a particular IDE. For example, I want to download Eclipse IDE. Okay. So I'm using Photon, by the way. You can just say Photon for Java enterprise developers. Okay. Any version is fine. You just have to have a integrated development environment for you to do Java coding. And once you go to this link, you can download. See, this is for Java EE developers. You can download the appropriate version. Okay, once you have downloaded and installed that, and you open the Eclipse for the first time, it will look something like this, right? So go on to File, click on New, and you may not see Java project initially. That's perfectly fine. I'll help you out. Go to Other, go to General, or you can see there is a Java folder, by the way. So go to Java and click on Java project and click on Next. Okay. You can give a project name. Let's say Java all. Okay, we are going to learn entire thing in Java. So you can basically configure this JRE. Okay, so what you need to do is click on configure JREs and you need to add the location for your JDK. So I've already added it for, but I'll quickly show you. Click on add, click on standard VM. Okay, select the directory of your path where your JDK is installed, which is this path. Select this folder and it will automatically get the name. So you can keep it the same name, JDK 1.8, and that is it. You can click on finish. So you can see I have a variable name created. So you just have to select this particular variable and click on apply and close. So that will be your JRE where your entire code is going to be executed from. Okay, and this is the location where your Java is going to be project is going to be saved under this particular workspace. So click on finish, and here we go. We have created our first project in Java. Let's do a simple coding now. Just get comfortable with the syntax. Just a minute. And here we go. Expand it. You will have a source folder. Right click on it and click on new and go to package. So we can create a package. Package is like trying to group all the different code files. So let me say basics because we're going to first learn basics of Java, and ensure your name is always in a small case, all of them. That is how the naming convention is for a package. Right click on it, and now we're going to create a Java class. So click on new, click on class, and let's say hello world. This is a popular thing which we learn, right? Any programming language with. So let's get started. Are you all excited? I'm too excited to teach you all this from scratch. So let's get started. Okay, so once you have opened this particular file, you would see that the first line in this code is going to be your package name, means which particular package your file is a part of. If you don't have any package, it will be a default package, by the way. So if you do right click and if you try to click on new and if you click on class, right, it asks you which particular package you want it to be a part of. See package, right? If I remove this package, see it is giving you an option that it will be saved under default package. So this is what I'm talking about. So currently it's under package basics and we have the naming convention like this way. We have to give an access modifier. So we are giving access modifier here as public, means accessible by everyone. The keyword class will denote that this is followed by a verbiage, which is for the class name. So hello world is a class name here. And this is the scope of your class. This curly braces indicates the scope. Means your scope is only limited till here. Whatever you do inside it, it is going to be limited till here. Its life is still here. Then you need to have a syntax followed. Wherever your execution is going to start, that method is called main method. And we have it as public static void main. Okay. And it will have one array argument, which is a string array, basically indicating that user can pass on to it at runtime multiple arguments to this main method, and it can utilize these arguments whenever it wants for execution purpose, right? What is static, what is void, and all that, don't worry, I'll keep explaining you all in detail about that when we come to methods. This will be pretty much clear. Okay, for now we are just going to concentrate on writing a simple print statement in Java. So the way to do that is you need to write system. Yeah, just a second and we will look at it. Okay, so there was a small error here. So let's write the syntax. System.out.println is the method which we need to use. Okay, and I'm going to give certain string within this println here. And in this one, I'm going to just say, okay, I'm going to increase the size of the font so that it is clear for everyone watching the video. So let's say hello world, right? Let's just say hello world. Okay, and that is it. So if you see, there is no error being shown. Okay, and by the way, I just wanted to let you know that you need to end every statement in Java with a semicolon, except for class or method definition part, of course, because those are starting with curly brace here, right? But any statement within this class or method, you need to end with a semicolon. So you can see here that it is giving me a compilation error multiple, so you need to insert the semicolon to complete it. So let's complete that, and you can run it with different ways. So you can either run it from command prompt or you can run it from Eclipse, but let's go by a simpler option here. Let's click on run. See, it's saying launching hello world. So how it works is that in the background, just to keep it simple, but I'm just giving you all the idea about it. In the background, there is a Java compiler which will compile this file and it will generate a dot class file. Okay, that is called basically like a bytecode file, and that bytecode file is run by an interpreter for that operating system. So we are running this in Windows operating system, right? So for Windows, we have a separate interpreter for Java bytecode language, and that will interpret that machine language to translate to whatever the user can understand as per the data or the code which is supposed to be doing, right? So this is how the output is generated from a Java interpreter. Okay, let's go one step ahead. Now let's just try to make it more, you know, more concise to what topic you're going to learn. So after this, let's try to learn the next topic, which is variables and data types. Okay. So I'll say variables, data types, because we are going to learn both of them in conjunction. Okay, so I've just copied the code file and let's get started. Okay. So what we will do is we will do everything for now inside main. So what I'm going to do is I'm going to create a data type called int. I'll say num1 equal to 20. Then let's say float num2. I'll explain all these, don't worry. Okay. 0.5, let's say f, and then we have double, let's say double val equal to 20.00d. Okay. Then we have character, let's say c1 equal to c. Fine. What else we have? We have string variable, right? String is another data type. Let's say name equal to Srini. Okay. Then we have boolean. Let's say bool equal to, or let's say status, for example. Let's keep it a very meaningful name, and we'll say it as false. Okay. Then what next? We have short, we have long, we have different data types. I'm just covering whatever are important to be known. So let's say s1 equal to, we can have a short value. Okay. We can have long variable. Let's say, for example, I'm going to have some long value. Now there are some limitations as well. It may not allow you to store a very long value, so there are some size limitations for different type of variables. If you see here, it's giving me an error that it is out of range, right? And here there is semicolon missing, so I can reduce it to whatever maximum it can allow. So if you see it, the error is gone. Okay, it's a very basic session we are going to cover in this today's topic. So if you want to know the detailed root cause of any particular topic, please do let me know in my comment, and I'll create a separate video for that. Now, once these are done, what you would like to do ideally is you would like to print these values, right? Let's just print all these values, and this is how the data types are in Java. So for example, if I say num1, if I want to, let's say, print num1, we use a concatenation operator. If you want to concatenate, let's say, an integer or a number or a string with a string, this is a string, by the way. A string starts and ends with a double quotes or with a single apostrophe. Okay, either you can use this way or you can use double quotes. Okay, so I'm using double quotes here because this is more convenient. And if you look at the character way, how it is defined, it is within single apostrophe. So mostly the strings are always written within double quotes in Java language. But if you are using Python or anything, don't get confused with Java. Java uses, for strings, it uses double quotes. Okay. Now I'm going to append the value of this variable num1. Now let's say I want to also print num2. Okay. So I'm going to again append num2. Like that, we can keep on appending. This is the way we need to remember, and we need to put a semicolon. So here in Java, the execution always happens from the main method. Okay. So let me run this program, run as a Java application. And here we go. We have got our output. So that covers the topic of variables and data types. Okay. Now let's just go one step ahead and let's try to learn some other concepts. Okay. Now let me call it as arithmetic, or let's just call it as operators in Java. We need to have certain operators as well for us to do certain actions, right? So let's say first thing which you're going to learn is arithmetic operators. Arithmetic operators in Java. So let's say we have int num1 equal to 20, int num2 equal to 30. Okay, and now we want to do certain calculations. Let's just again say, now by the way, we have a shortcut to write system.out.println. You just have to say syso, then control space, and you can see we have to double click on the sysout. Okay, so let's do num1 plus num2. So this is the plus operator. Okay, so likewise, I'm going to talk about all the operators. So plus, we have minus, we have multiplication operator, that is asterisk, we have division operator, that is forward slash, then we have a modulus operator for getting the remainder, right? So these are the different operators which we need to be aware of. Likewise, you can do the arithmetic calculations. Now there are, so these are basically called arithmetic operators in Java. Okay, so I'm just going to write a comment. Okay, so this is how we write a single line comment in Java. Comment is something that we don't want it to be executed as a part of our code. So this we can basically, compiler will ignore to do any execution or compilation on that. Then we have assignment operators in Java. Okay, we're talking about operators in Java here in this particular file. So we have equal to, we have minus equal to, we have plus equal to, we have not equal to, right? Then we have multiplication equal to, we have division equal to, right? We have modulus equal to, etc. Okay, we are talking about the important operators here. And then we have logical, let's talk about this way, comparison operators. Comparison operators is another important topic. It can be greater than, it can be less than, right? It can be greater than equal to, it can be less than equal to, or it can be double equal to, right? So these are the comparison operators which we have, and we have not equal to, right? So not equal to, let me cover it here, right? Assignment operator, this is enough to be known. Okay. You can either subtract, you can add, you can multiply, divide, or you can find out the remainder, or you can simply assign a value. Now then next we have, so we have logical operators in Java. That is, we can use double ampersand for combining two expressions within certain looping statements, or we can also use or. So this is basically called or, this is called and. Okay. This is what we need to keep in mind. So these are the different types or different categories which of operators which we need to know in Java. Now let me show you an example. Okay, I'm saying, for example, here I'm trying to assign the value of num2 from 30 to 40. So always after creating of a variable, if you want to change a value, you can always change it using the assignment operator, which is equal to. I can also do this way that num2, I want to basically do num2 minus num1. Let's say I want to do this action. So why do we need to write in such a complicated way? Why not try to do it in a simpler way? So for that, we have a syntax. We just have to say minus equal to. So this will mean num2 equal to num2 minus num1. This actually means num2 equal to num2 minus num1. Okay. So likewise, the first operand will be the way the value will be stored, and the second operand on the right hand side is what will be used by the operator, which will be the second operator. Okay. Comparison operators are used basically if you want to compare any value. So when I cover the if and the other statements and loops, I'll cover this comparison operator and the logical operator. So stay tuned for that next part. So we'll go to the next part now. So this is all about the operators which you need to know in Java if you're going for a quick revision, right? Now let's go for the next concept, which is loops, or let me say conditional statements. We more precise. Right? So the next thing which you need to learn, the important concept in Java is the conditional statements. Okay. So far we have been working only with main method. Don't worry, we will go further into the next concept. Now let's just go one step ahead. Int num1 equal to 20, int num2 equal to 40. Okay, now comes the first part. We have a conditional statement in Java called if stands for if you want to compare or if you want to check anything, right? A condition or expression, those would be within this parenthesis. So I would say here, if num1 is greater than num2. Remember I had told, I'll explain about the operators related to relational operators, which is here, right? So we had this different comparison or relational operators. So that is what we're going to cover now, this greater than, less than, etc. So if number one is greater than number two, then we can have a curly brace. Okay. If you have multiple statements. So let's say there is statement two, there is statement one, right? If you have multiple statements, that is more than one line of statements, then you need to use curly brace compulsorily. Otherwise, what would happen is this statement two would not be a part of your if block. Okay. So if you don't want to for that to happen, always ensure you have curly braces put for if you have more than one line of code within that. If there is only one line, then no need to have the curly brace. You can simply write like this. This is all what is important. So let's say I'll just show that right away. Num1 is greater than num2. Okay. This is what I'm talking about. So let's try to execute and see. Now, what if this expression doesn't evaluate to? So this we are expecting to be true. This condition, if it is satisfied, it will give us an output true, right? If that output is not true, then this will not be printed, right? But what if I want to print if this is not printed? If this is not executed, I want to still do something else. So for that, I have else block. Again, the same thing applies to else. If you have only one line of code, you can write without any curly brace. So I would say here, num1 is lesser than num2, right? A very simple logic, a simple code, and that is it. Let's run it and see what is the output. So run as conditional statements in Java. We are getting output num1 is lesser than num2, right? Now, what if I want to have multiple statements? Now let's try to have blocks of code. Okay. So I can have a blocks of code like this. Similarly, for else, I can have a block of code like this. And I can simply write something here, right? I can do some expression, or I can just write, let's go to. So let's say if is ending here, something like that, right? I'm just trying to explain you all the conceptual part. Actual code you can definitely be able to write when you start working on some project. And let's say here, exiting else, something like that, right? Now, when you run this code, all the lines of code are going to be executed because you have put inside the block, right? Now, there is one quick thing which I want to show you all, that if you are trying to do any kind of a operation, right, within this if else, let's say I had certain code to be executed. Let's say I had this code to be executed, but I forgot to put this code within the curly brace. I put it here. This is going to throw you an error because you are following a if else syntax. If this else was not there, then it's fine. You can write like this way. But if else is there, you need to always ensure if is followed by else. You cannot have any line in between. But you can have this after else. This is fine. Not a problem. And you can always format the code as well. Right click and you can basically format it. Okay. So there are formatting options available where you can format your code in a better way. Okay. So we'll go into that in a later point of time. But now since we are covering Java conceptual things, let's continue with this concept. Okay. Now you can also have one more thing called else if. What if num2 is less than num1? Okay. I can also have another condition like else if. And here I would say num2, yeah, this is also fine. And I can have finally else block. If num1 is not greater than num2, then definitely it'll go to the second part. If this is also not happening, then it is definitely, this is the condition which is satisfied. It may be equal. So this is the equal to operator, which we are talking about here. Double equal to operator is for checking the equality between the two values, right? Or two expressions, which is we're checking here. And now here we're going to say again, sysy so control space, both values are equal. Okay. I hope this is clear. So this is how we are going to have. So you don't need to have else if here. So if you don't want to have else if, you can comment it like this and you can try to put your curly brace starting from here. Right. So this is what we are having overall. Okay. So I'm saying code is ending here. Fine. Let's run it. So that is all about the if else part. And also we've covered some operators. And you can see that both the values are equal and code has ended here. Okay. Now, what if you want to combine some multiple expressions, right? So, for example, there may be a situation where you may need to combine multiple expressions. So you can use double and operator and try to use a and condition here. And here you can try to go for or condition. So I can go for this or condition and I can use this parenthesis for another expression. So let's say here I'm going to say something else. Let's say it's greater than 0 and num1 is less than num2, which is satisfied, right? Because 20 is greater than 0 and 20 is less than 40. Here I'm going to say num2 is less than num1, okay, which is not satisfied by the way. Or I would say num2 greater than 10. Is it satisfied? Have a look. Num2 is 40. It is greater than 10. So this is true. But this is false, right? It is not less than num1. So false true, false or true is going to definitely give you true, right? It's not a and, it's a or. In this case, num1 is greater than 0. Let's say, for example, I make it false. Okay, num1 is less than 0. No, this is going to be false. Num1 is less than num2. Let's make it more. Okay. So this is also going to give you false. So when this condition evaluates, this is not going to get printed, right? Why? Because this and condition is going to make it false, right? That basically the value here is, let's say this was less than. Okay, this is correct. This is true. num1, 20 is less than 40, but num1 is not less than 0. So what we are ideally trying to do is we are trying to do false and true, which is going to give you the output as false, right? So that is why this particular thing is not going to get printed. It will not go inside this block of code, but it is going to go inside the else if. And if it is going inside the else if, means else won't be executed because else if got executed. So let's run this program. And that's our logical operators also. We have seen the action, right? Num1 is greater than num2 and exiting else. Just a minute. It has executed this code. Yeah, this is correct. We have got the two blocks of code executed. It has not printed the else part. And then we are printing the last thing. Code is ending here. So this was about the conditional statements in Java. Now, it's not completed yet. Actually, you've seen only a small part of it. Let's go for its part 2 and let's look at what exact things are there inside the part 2. Okay, so basically let me copy it and paste it here. Yeah, so let's call it as yeah, 2 should be good. Okay. Now in this, we are going to look at the other types of looping statements. We have file, we have while, we have for, we have do while. Okay, we have switch, and we have break. If you know these different constructs in programming in Java, you can definitely start writing programs, and it's going to help you to understand how the code gets executed, how the flow of the code is, right? So it's going to be very important, guys. So let's get started. So now, instead of using if and all that, let's remove all these things, right? Let's keep it simple. Let's implement this main method. Okay. So again, I'm keeping two variables. And for now, I'm going to start with while. So while, let's take a counter. Okay. Let's take a counter. So I'm going to say int counter equal to 10. Okay. What am I going to do? Let's have a look. While counter is less than 40. Okay. While counter is less than 40, I'm going to do certain action. Okay. I'm keeping a track of that counter. And then after my statements, whatever code I want to do here are done, I'm going to do counter equal to, so I'm saying plus equal to, so counter equal to counter plus, I'm going to increment every time with 10. So what happens after the first time when it's trying to enter inside the while, the value of counter is 10. After the execution of these statements are done, before it goes for the next check, we are incrementing the counter by 10. So 10 gets added with 10, it becomes 20. Like that, it will come till 40. As soon as it reaches 40, this 40 less than 40 will not be true. It will come out of that loop, right? So that's what we're going to look at now. So let's do one thing. Let's, for that iterations, let's try to uh, add the values. And let's first say iteration 1, iteration, and let's keep a count of that. So I'm just saying int tracker equal to 0. I'm keeping a track of the values. So first iteration, when I'm going to say plus plus tracker. So this is another operator. So in operators in Java, we have another operator which is basically, I'm just going to put this category here, like unary increment and post increment and pre increment operators. Like example, you can have a variable like plus plus a, or you can have a plus plus for a post increment. Likewise, we have for decrement also. So I'll explain you what exactly these are. So these are unary operators. So what happens here is that first you are incrementing the value of a by 1, and then you are using this particular variable. Okay. A plus plus means, let's say if the a was having value 10, you'll use the value 10, and after that usage is done, you're going to increment by 1. Likewise for minus as well. So here, now we are going to do plus plus tracker, means we are incrementing the tracker by value 1, and then we are showing it here because we want to increment this 0 to 1 and then we want to show it here. That's why. Okay. And that is it. And that's what we want to do here. But still, if you want to add any values also, you can do. So let's say I want to do certain action here. So depending upon the tracker, let's say I want to multiply. num1 into, or I can add basically num1 plus num2 plus tracker. So first time when it is adding, it will be adding 1, then it will add 2, 3, like that. And at the fourth time, it is going to be coming out of this loop because its counter is equal to 40. So let's run this program. Okay. What is happening here? 40 plus 20 is 60. 60 plus value 1 is 61. Iteration 2, it is 62. Iteration 3, it is 63. As soon as counter becomes 40, this comes out of the loop. So this is how the while loop works in Java. I hope this is clear. Let's look at the next one, which is for loop. I'll write the syntax for you all to explain. So let's say counter 1 equal to 0, counter 1 less than or equal to 10. So this is how we have the less than operator used, and then we have counter 1 plus plus. Again, we can use curly braces if you have multiple lines of code. Same thing applies for while, for if condition. If you have multiple lines of code, use the curly braces, right? What we want to do here, we want to start printing the value of counter. So let's say counter, okay, let's just say this way, counter, and then you want to simply add the counter variable, counter 1, right? So this execution will go like this. First, it will start value 0. This is how we define a variable, counter 1 equal to 0. Then after every iteration is done, after once the block of code is executed, once it comes ahead again for executing it again, it will check, is this condition satisfied? If it is satisfied, fine, it will again go inside. After this execution is over, it's going to increment the counter. So first time when it comes inside it, it's going to have the value 0, right? Then you increment the counter by 1 because it says counter 1 plus plus. Okay, means you print the value 0, then you increment it by 1, so it becomes 1. So counter is equal to 1. Then you print the value of counter 1, which is 1. 1 is less than or equal to 10, yes. So you go inside this and print this statement. So like that, it is going to go till counter 1 is equal to 9. So when it goes here till 10 actually, because we are saying less than equal to. So when you come to here, when counter 1 is actually having value 10, it will say 10 is less than equal to 10. Yes, it's going to go inside. So it is going to print the output from 0 to 10 because we are executing it that many number of times. So let's run it and see. Okay. So you have seen here that it is printing the counter 0 till counter 10. As soon as it comes outside of this loop, this execution is over. For loop execution is over. Now let's understand what is do while. Do while will be like, this is the syntax for do while. Let's say f is greater than, let's say f is less than 10. Okay, let's say here we have a variable called f equal to 5. Okay, so currently what you can see here, we need to put semicolon to end the do while. So currently what you can see here, f is instantiated, so it is initialized to value 5, right? And I'm going to do certain action here. Let's say I'm going to say f, again I'm going to print it. But after that is done, again I'm going to increment f by 1. Okay, so 5, 6, 7, 8, 9. As soon as it reaches 10, what is going to happen? It's going to come outside of the loop, right? Because f is no longer greater than, less than 10. But here is a catch. Okay, I want you all to understand this thing here, that if the first time when you execute this code, if that time itself, let's say the condition is not found to be true, then what will happen? Let's say f was 11, f is 11. Okay, and then I'm saying do while f is less than 10, but 11 is not less than 10, right? So will it execute the code? It will execute, because first time when you do, it's do and then you check the condition. That is how the do while works. While was different. While was first checking the condition, then you execute the code. But do while is saying you first execute this code and then later on you can check the condition. So let's run this program and see what happens. You can look at this code that it is printing f equal to 11, even though 11 is less than, not less than 10, it is more than 10, right? So that is how your do while works. So we have seen how if works, while works, for works, and do while works. Now we also have one more particular thing called switch statement. So let's say switch case. Okay. So let's say, for example, that I'm going to show you this thing. Let's not say case here. Let's say status. Let's just have a variable called string here, and we'll keep the status as. Okay, we'll just keep the status like this way. Let's say status is pass. Okay. Or let's just try to keep it a very realistic example. So let me say this way that double, let's go for int actually. Int total marks. Total marks. This is like a very realistic example. Okay, if you want to separate a variable, you can always use underscore. Total marks, let's say I'm uh, obtain marks. Let's say this way. This is more better. How much a student has obtained marks? Let's say the person has obtained marks 70. So I'm going to put here a switch for obtain marks. Okay. Here I'm going to have a case. Let's say I'm talking about a value that's 70. What we should do? If it is 80 or 60, etc., what is this print thing? What I want to do exactly with that code, right? So like that, it's like a grade we can consider or like a marks we can consider. So let's say if it is 70, then I'm saying this is first class. I'm just trying to show you all how the switch statement or switch case works. Likewise, we can try to have the grades for each. Okay. This we can say is second class. This you can say is, uh, let's say, better class, something like that. And this, let's say, is distinction. Okay. So normally I can try to change the definition here a bit. Third, second, and first class is better. Okay. And then finally we have distinction, which is the highest grade. And after every case, we are going to put a break here because we want to, as soon as this condition is met, for example, the 70 thing is met, I don't want to keep on executing 60, 80, 90 because I have already reached my place where exactly whatever I had to do, I have done that. So I can break it. Likewise, I can break it here. So this is demonstrating the use of break as well. Similarly, you can use break in loops as well. I'll show that as well. And like this, and you can have one default case here. Default, if it is 0, then you can say the default. I can simply say, in case it is not matching with any of these cases, then simply I will say no value matched. Okay. So I'm trying to explain the core concepts. So it may be the case that I may not be able to cover everything within an hour, but I'm trying my best to cover all the things from scratch as well. So that is how we are having the switch statement, and we have break. Now, if you want to use break inside a loop, let's say if counter, I can put a if condition also within a while loop. If counter is equal to 30, so take it, right? So this is how we are using double equal to operator to check a value. So what I'm saying is, if this condition is met, I want to break the loop. Okay. And let's say I am printed with count with iteration, something like that, right? I just want to also print if this iteration statement is printed or not. So I can go for tracker. Okay. So in case our code doesn't get executed after this part, this line won't be printed for that tracker. That is what I want to check here. So let's run it. So this is how your break can also be used. If you want to break out of the loop, if certain condition is met, then you can also do that. So let's say, where is counter? Yeah, iteration 1. I'm printed with iteration tracker 1. Iteration 2 is going inside. Okay, it's printing 62. Okay, but counter is equal to 30. Because of that, it has broken the loop, and that is why it has not gone ahead to execute the remaining statements after that. So that is all about the conditional statements in Java. I've explained all the things in detail. Now let's look at the next conceptual thing. Okay, that is going to be class and objects, which is very important thing in Java. So we're going to look at this concept in detail, and also we're going to look at functions. So this is going to cover your, slowly we are covering inside the oops now. So if you want to change your name, you can always go to refactor and class objects functions. Okay, let's come on to this topic now. This is the most important topic in Java, and now we are ready to get started. So how do we create class in Java? As we have seen before, we have to write an access modifier like public, then class keyword, then class name, then start the curly brace. You would have a main method. You can also have certain instance methods in Java. We are going to cover now instance methods. Java means for each object of class, they can have this method called. Okay. Then we have something called static method. So all the objects in Java for the class, let's say for the class, will share this method. Basically, it is shared amongst all the ones. So same is the case for variables also. Be it variables or methods. This is how this concept works. So how do we create a static variable, instance variable? Let's deep dive into it. So for instance variable, okay, you write like this. You would say string name equal to, let's say, John. Okay. This is an instance variable. Means for every object, there will be a name variable which will be unique. It will not be like a shared amongst all the objects. Or I can also have a static variable defined like this way. I can have, they all might be studying in a particular college. So I can have static keyword put in front of that data type. So this is data type, by the way, right? String. And then I can have college underscore name equal to send Jude, for example. Send Jude's college. Okay. This is static. So whenever we want to have static, means this value is going to be common across all the objects. We don't have to change it, or the objects need not have a separate value. Then we can have it static. So college name being static makes sense, right? Because they are studying in a particular college. Likewise, we can have methods in Java, right? So now we're talking about normal methods, and we'll talk about the static methods also. So let's say we want to assign these variables some value, okay? And we want to print the value. So let's say I want to have a method called get details, which is simply going to get the details of these values. So I'm going to say public void. I'm not going to return anything. So if you are not returning any value, you have to use a return type as void for the method get details. And then I can use this out, say name, use plus operator. Then you have to use this keyword. So using this means whichever object is calling, whichever object is using, we are using to call this method, for that object we are trying to say this dot access the name. Okay. Likewise for that, if you want to access the college name, you can say like this dot college name. Okay. So this is how we write a normal method in Java, like instance method. Okay. Now we can have a static method also. So for that, you can say public static void, and you can say get college. So this, by the way, is not supposed to be done, because you're trying to see it's giving a warning. It's not an error, it's just a warning that it should be accessed in a static way. What they are trying to say here is Java compiler, that since college name is a static variable, you should use a static method to access a static variable. So let's just take out this from here. Let's abide by their warning, even though it's not mandatory. And still, there is no error as such, but we will access it in the proper way. And you don't have to write this dot here, because college name is a static variable. You can directly write college name because it's a static variable. So always static variables you can directly access by the name of the variable, or you can also access them by the name of the class dot static variable, because they are belonging at a class level, not at an object level. Okay, right? So we have done this thing so far. We have created instance variable, static variable, instance method, static method. Now it's time to look at the objects concept. So in Java, we can create an object by using the class name, then give a space, then give object name obj, for example, equal to new obj, or let me say stud, because we're creating a student here, equal to new, use the same thing, and then put a semicolon. So what this new does is that it is allocating memory for this object at the Java heap memory, means somewhere this object will be stored, right? And using this object now, stud, we can use a dot operator and then access all its methods and its variable, but provided they should be in a accessibility mode, means you need to use proper accessibility. Like example, if you see, right, the class is having public, means anyone outside this package basics can also access it because it is public in nature, right? So likewise, whichever ones it can access, it will be able to access within this class. So it can access name, it can access, let's see which all methods it can access. It can access get college name, which is static method. It can access college name, which is static variable, right? So let's just get the value for, let's try to access the method, which is get details. Okay. Now we want to directly access this method now, static method, which is get college name. How do we do that? It's simple. We just have to write class name. Directly also you can write this way, but the better way or the right way to do so is using the class name and access the static method. Okay, let's run this program and let's see what output it gives us. So it has given the name of the student John and which college the student is studying. Likewise, you can have multiple objects created, right? And you can try to, let's say, create student one, and using the student one you can try to get the details, but then you're not setting any name of the student, right? Every time it will be otherwise John, right? So what you can do for that is you can just say default and create a method which is to set the value, public void set name. Okay, get the name from the user. So let's say string name. So notice here that I'm using the same variable name for here as a parameter for the method set name as well as for the instance variable, but I can try to make that assignment clear without any ambiguity by using this way. What I'm saying is, for this object's name instance variable, assign the local parameter name. Okay, so first we need to call this method and then we can try to do get details. So we can do the same here. We can use stud.set name and we can say John here. Okay, and again for the student one, before we do get details, we can say student one dot set name, and I can say Johnny here, for example, and then I can simply try to get the details of this one and then get the college name, which is not going to change because college name is a static variable. Okay, so let's run this program now. So we can see that for John, this college name is St. Jude's College. Similarly, for Johnny, the college is St. Jude's College. So this is a very simple example which I've taken for class and objects, and also introduced the concept of instance variable and the static variables. And also we covered this concept, right? Okay, so we are very much close to understanding one more concept now. So let me introduce one more concept in the same one, which is constructors in Java. Okay, so what are constructors in Java? Constructors in Java are methods which gets called whenever you create an object of a class. So you can see that we have called this particular method class object functions, but you would have noticed that in this file I've never created this particular method, right? Class object functions. It's just a class name. So how was it able to call this method, right? So basically it called the implicit constructor, which the Java compiler gives us by default. And if you don't override it, in a sense that if you don't change the definition, if you don't create this method name again, it is going to call that implicit constructor by default. Okay. But let's say that there may be a situation, and there is definitely a situation in future. If you work on projects, that you will come to know that you need to assign such variables at runtime. You don't need to use setter method. You need to use a method like this way actually. So you can comment it for now. Instead, what happens in a real life situation is that you say like this way, public. So try to copy the name of the class here. Okay, like this. Now don't give the return type here. So this is a constructor. Okay, for constructors we don't have any return type explicitly. Implicitly returns you the object, but we will not be having any explicit return type here. That is how we call a constructor, and the name of the constructor will be same as the class name. And this, by the way, is called a parameterized constructor. This what we are looking at is a parameterized constructor. So this parameters constructor takes the object name. So here we can again say the same thing. This dot name equal to name. So whenever you are calling the object of this class, you are also assigning the name. Okay, in this particular method, constructor method. So what happens now? So you also have to. You don't have to write this method definition or invocation here. You can pass this as a value within your method. Okay, and like this way we can initialize the value at our runtime whenever we are creating object the constructor value. So like that way it's going to set your instance variable to that value. So let's run this program now, and you can see that the output is exactly same what we had before, right? So this is the pure core concepts which you need to know in Java. You need to know about class, objects, constructors, right? Now we are going to go at one more level further, is that we're going to look at interfaces in Java. So what I'm going to do is that I'm going to create an interface. Let's say interface one, and I can use again an access modifier like public. And in this interface one, so yeah, if I use public, it will basically ask me to create in a separate file. So if you see here, public interface must be defined in its own file, which also you can do. That's not a problem anyway. So for now, I'm making it just within this one. So this is like a default access modifier. There is no access modifier given to this, right? So this is called default access modifier. Okay. So before we go to interfaces, let me just list down all the access modifiers so that it's clear what exactly it means, right? So we have default, we have public, we have private, and we have protected. Okay. So default means if you don't mention any access modifier before any interface or any class, right, or any method, then that access modifier is called default. What default access modifier means is that it is accessible by any particular entity or a class within the same package. So if you see here, we are under basics package. So all these files are currently under basics package. So it is accessible only within this package. Okay. This is how we are having default. Now, if you create another package, let's say I create a package called advanced concepts in Java, right? So then any class under advanced, for example, collections is an advanced topic. Okay. So let me create collections in Java, for example, right? So any class which is there here inside this package will not be able to access the content inside basics because the access modifier which is defined for this interface, which I showed just now, is actually default. Okay. But if I make it public, even collections in Java can access this interface, but I can't make it here because I have to put it in a separate entity. So that is the reason I'm removing this part for now. But it can access class object functions from collections in Java because class object functions is made as public. Okay. Now the other one is private. Private means only within this class. Let's say I have a particular access, like I can say here int roll number, for example. Let's say roll number is 10, or let's say default it set it to 0. I'm just saying it as private for now. Private means only within this class roll number is accessible. No one from outside this particular file, class object function, outside this the conditional statements or hello world or operators in Java or any other package files cannot access this variable called roll num because it is made private in nature. So this is done for the concept of oops called encapsulation. Basically, we are encapsulating the private things inside a particular kind of a capsule so that it is not being allowed to be accessed from anywhere outside. So for any private variables, we also go for setting the value and also getting the value. So we try to have a get roll num. So normally the getters are public in nature because it should be accessible by anyone to access the value. If in case we want to allow it to be accessed, then we can have it public. So of course there is not going to be any parameter required here. If you want, you can give return type as int here and simply return this dot roll number. Okay, this is how we use getter. This is called getter method. Okay, for a private variable, and we have something called setter method for a private variable. Means for setting this value, I can make it private again because I want only this particular class to be able to set the value, but I don't want to have any return type. So I can say set roll num, and I can take the value of roll num as a parameter, and I can say this dot roll num is equal to roll num, which we have got from the user, right? So this is a setter method and this is a getter method. So this is how we can maintain encapsulation within our code so that it is not being allowed to be modified from outside our current file or current class, right? So this is the private concept. Protected access modifier means what? Protected means if in case this particular class, let's say, okay, let's call this particular class parent class. Okay, and I'm going to talk about one more concept. So yeah, anyways, you're going to look at interface also, don't worry. But let's cover one more concept called inheritance in Java. So this is the parent class, right? Now let's say I want to have, this is class object functions, right? Let's say I want to have another concept which I want to cover. Let's call it as subclass. Okay. So as the name suggests, subclass means it's like a child class. Okay. So this class is going to extend. So we use inheritance by using extends keyword, and we want it to extend our parent class, which is class object functions. So when it does that, what happens is that, yeah, so we need to, I'll come to this point. Don't worry about this error. So when we are trying to inherit some other class, what happens is it is going to be able to access everything as a part of the class object functions, but there is one small limitation to that. It cannot access private. So this thing it cannot access, this thing also it cannot access, neither the method neither the variable, but it can access the protected ones. So for that reason, if you would have made this instead of private as protected, then it will be able to access it, because even though it's in another package. Yeah, so let's do one thing. Let's make this subclass as a part of the advanced package. So even though it's a part of separate package, still it will be able to access your parent class. Okay, so what you have to do is you have to add a explicit constructor. So in inheritance, we need to always keep one thing in mind, that if you are having a subclass inheriting a parent class, you always have to have a constructor created for your subclass. Okay, and it will be trying to mimic how your parent class is having a constructor. So if you see the parent class constructor, right, it is having only one parameter, string name. So same way, if you see for subclass also, we have only one parameter, but you have to call inside this subclass constructor. The first statement should always be calling the superclass constructor, because you are extending this from your superclass, right? So this is the first constructor which should be called. And after that, you can have any lines of code within here. You can try to write anything here like subclass constructor, or you can try to do any coding which you want to do here, any assignment, etc. You can also have, for example, int num2 equal to 10. You can have separate, so you can have basically like separate variables like int num2. Okay, this is perfectly fine. So this dot num2 equal to num2. So only the name thing I'm trying to pass it to my superclass constructor, because it is needing only one parameter, which is name. Remaining things I may be using it for my purpose for subclass. This is also perfectly fine. So this is the concept. What we are trying to do here is, here we are trying to call the super, that is nothing but the parent class constructor. When you are trying to call your subclass constructor, your parent class constructor has to be called as a first line using super keyword, super constructor method, right? Right. Now there is one more important concept since we are covering inheritance. Let's say in class object functions, you have a method. Let's say you have display method, right? Get details method, for example, right? So now if you want to define the get details method inside your subclass, so you can say public void get details. You notice it, there is a small green arrow shown here. It says overrides basics dot class object functions dot get details, means whatever was the definition inside the parent method, I am trying to override it. So I'm going to say here overridden get details. So here you can use it for your own purpose. So rather than using only for name, you can also print num2, right? So what would happen now is that even though don't worry about name is already been inherited from your class object functions. So your name is already a part of your subclass. Okay, even roll number also, because roll number we have made it as a protected field. If you see here, roll number is also inherited because roll number we made it as a protected. So if your subclass, it could be in some different package or it could be in the same package. Even though it's in a different package, it can still access roll num because we are making it protected. Okay, now there is small difference here. If you make it default, then what will happen? Then your subclass can't access roll num. So let me show you. So for example, if in this particular constructor, let's say I want to access using the object of subclass roll num. Do you see roll num is appearing here? Roll num is not appearing, right? Why? Because I made it default, right? But if I make it protected, then roll num would start appearing after I use the dot operator. And now you can see roll num is appearing. So this is how we can access also a protected variable. So let's just complete this part. Roll number is equal to, and then access it using this dot roll num because it is already inheriting. Okay, it's inheriting from your superclass. So we will see that in the main method here. So let's create an object of our subclass now, and let's look at this magic, right? So let's create a object of subclass obj2, okay, equal to new subclass, and now we need to pass two parameters for our constructor. We need to pass num2 as well as name. So let's do one thing, and we can just look at this thing also. We can also access roll num and we can assign it to num2. This also we can do. Okay, so that way we are covering that part. So let's first pass the name and the num2. Again, I'm going to pass name as John and I'm going to pass as 10. So roll number 10 is going to be set for John. And using this obj2 object, I can access the variables as well as the methods. If you see, I have method for get roll num, I have method for set roll num because it is made as, what is the default, what is the access modifier? It is default here. Similarly, for set roll number and get roll number, it is get is public, set is protected. So even though we have public, we can access it from anywhere. Protected can be accessed even by a class which is outside the current package, which is advanced can also access the set roll number. Okay, similarly for roll number field as well. Okay, so let's access the different methods. So what all different methods we want to call? Let's say we want to call roll number. Okay, we want to also try to print the details, right? Get details method, right? Now get details method would be called here, but this is going to be the overridden version, means this would be called. Where is the get details method we have? This is the one, right? And here we want to also print name, roll number, both, right? And along with this number. So what we'll do is we'll say this out name. We'll say this dot name. Okay, just a minute. Let's see whether the name field we have made is private or something. Okay, so name, if you see, is default. That is why we are not able to get the name field. So this also, So what I'm trying to say is that if you see this dot, I'm not getting name, right? That indicates that it is not able to access because this is present in separate package. The subclass is present in separate package. So in order for it to access it, I have to make it protected. So we will stop after this concept and we will continue it in the next part of this Java overall series or overall course to be learned, right? Because I'm going in a very slow fashion so that you can understand it. Now I can see name is accessible. And similarly, I can also try to append with roll number. Okay, I can say this dot roll number. And here we go. So we have completed our method overridden as well. If you look at this, it says overrides, and now we have actually done overriding. And see, it is going to call now in this get details method of subclass, not of parent class. Let's call it. Okay, now I want to show you one more thing. If you go to this particular thing, parent class, and let's go to its constructor. Let's try to also do print statement here in super class constructor, because we did not see this happen right in the background. So I want to show you what actually happens in the background. So let's do that and let's come to a subclass. Let's clear out everything and let's rerun it as Java application. And now you can see that when this particular thing got called, the new subclass, first line has gone to the call to your superclass constructor. Being called, right? And then it went on to execute the remaining statements like subclass constructor. It tried to override the value with 10, and then it got the details of name of the student as well as the roll number. Now we are going to learn one very interesting concept which is called interfaces in Java. So what I would like to do is in this superclass, okay, I have created an interface called interface one. Okay, so let me give it some name. Okay, interface one is fine, but I can just change the name to something which is like useful. I'll say reusable methods, something like that. Okay, I'm just giving some meaningful name. Now, whatever we define inside the interface, okay, now we need to talk about a couple of things here. Okay, what is exactly an interface? Let's talk about that first. So interface is basically like a template. Okay, it's like a template which the classes can implement. Okay, it is not like a class, it's like a template which the classes can implement, and every class can give its own definition for the interface methods. Okay, so there can be methods inside the interface and there can be variables inside the interface. Now let's talk about the methods first. So methods are going to be public and abstract implicitly. So without you writing any access modifier for the methods here, these are going to be pure declarations. Okay, they are not going to be definitions of methods. These are going to be declarations. Okay, variables are also going to be initialized. So variables are going to have value. So what would the variables have by default? It would be public, static, and final. Okay, what is final? Let's talk about that as well. So final means its value cannot be changed, like a constant. Once you define a value for this variable, you cannot change the value. It is final throughout the course of the program execution. Its value cannot be changed. Okay. Static means we don't need to have the object created. Basically, it's a variable at a class level. Like that's what we understand the value by static, right? So what do we understand by static? Is that the value would not be having a memory allocated for every object separately. It will be shared amongst all the objects. Public, as we have seen, the access modifier in our previous part, that public would be accessed by anyone, right, outside. So this is going to be the implicit values for the variables and methods. So let's give a variable name. Let's say name. But if I say name, I can't change the value. So this is going to be default. Okay. I mean, this is going to be always this value. We can't change it. So I am saying here string name equal to reusable. So if you see, it's not mandating us to put public, static, and final, but implicitly it will have this thing implied. So we will see in action shortly. Other thing is we can have method declarations. So we can have void display. Let's say I want to have every method display certain values. Okay. they can, of course, implement this interface reusable methods. They will be getting the string name variable. They will also get display, but every class, whichever is implementing this interface, would have a liberty or would have a flexibility in giving their own way of implementation. Okay. Let's create one more class. Let's say class one, and I'm going to say now implements reusable methods, right? This is how the syntax we need to write. Okay. Yeah, so we are getting an error because we have not yet given the implementation for the abstract method. Remember, this is an abstract method, right? This is abstract. Why it is abstract? Because we are not having any definition. We are giving only declaration here. And also within an interface, any method which is just given a declaration is implicitly going to have public abstract as a part of its access modifier, which we can't see, but that is the implicit understanding. Let's have a look at that. Okay. And that is why if you see, it is forcing us to implement the abstract method display. Now this message would be clear as to why in interface, every method is going to have abstract implicitly. So let's define the method. So I would have to write public void display. Okay. And just put the access modifier public here. I can say so we are just going to write the system.println for the display method. Yeah. Okay. So let's say inside class one overridden display method. Okay. So we have overridden the display method as to whatever value was there here. This interface, whichever we got it inherited from, we implement this interface, right? So we have given a definition to that. If you see here, it implements this method display. So this is the implementation of abstract method. Now, I want to show you one thing here, that in case if you try to reduce the visibility from public to lesser than public, so public is the highest visibility. If you try to make it protected, you will get an error. You see here, the reason being you cannot reduce the visibility of the inherited method from the reusable methods interface. Why it is so? Because implicitly the compiler is giving it public and abstract by default. So you have to implement, and you need to always have the public access modifier. You can't make it protected or less than public. That we need to keep in mind. Same is the case for reusable, that is the value name. We cannot change the value. Let's say if I try to assign a value name equal to, let's say, hello world, something like that. Just assigning it some another string value, and you can see we are getting an error that this is a final field and it cannot be assigned. So we can just write, you can just print it if you want to by just saying name. Okay. And it will be able to run it. So let's run this program. But first of all, let's create the object of class one inside our main method. So let's say obj equal to dot display. Let's run this program. Yeah, I think it's loading. Okay. So here we go. We are inside class one overridden display, and it has also printed the value. So we will just separate it by space. So that way we will be able to get a clear, and we'll say name value, give a space, and then we can rerun it. Okay. So this will give us a proper description of how the output looks like. Yeah, so here we go. We have got the value of the name variable as reusable. Okay. Now, what is the advantage of using interfaces? So interface basically gives us a template so that the all the classes can implement the interfaces. Okay, and they can give their own definition for the implemented methods. And once we do that, we can also basically implement multiple inheritance with the help of interfaces. So I'll show that. So let's do one thing. Let's create a separate class. And now we are going to look at multiple inheritance in Java, but it is not possible with the help of classes, but we can achieve it with the help of interfaces. So let's create a class and let's say multiple inheritance. So we have a subclass, we have another class created called multiple inheritance. And now we are trying to see if these two, if basically one class can extend multiple classes, right? So let's say I want to try extending. This is the way how interface work, inheritance works, right? We can write this subclass is extending a superclass, right? With superclass, let's give it the same name, class object functions. This is allowed, right? We are allowing one inheritance to be done. So in this case, you will have to import the class. So just a minute. Yeah, class object functions basics, right? So we have to first import the package that is basics class object functions. And what is this error? So we need to define a constructor. Fine, we are doing that. Okay. So this is the basic thing which we are allowing in Java. This is called single inheritance. Okay. So now we are looking at the different types of inheritance in Java. This is called single inheritance in Java. So we are supporting multiple types of inheritance. We looked at interfaces. Now we are looking at inheritance in detail. Other type of inheritance which you have is multi-level. And then we have hybrid, means a combination of multiple inheritance types. So what we will be doing is for the multi-level inheritance, what we will be doing is we will have another class which is extending multiple inheritance. So let's say class multiple inheritance 2, or let's say inheritance 2 extends multiple inheritance. So what we're doing here, we are trying to have a multi-level inheritance now. So means this is our parent class. Then we got a child class created. Now this child class is also been inherited by another class. So we will have to write this way, right? So let's create a constructor. So this is called multi-level inheritance because what is happening? You are having one level above each other. So one class is being inherited by another class and this class has been inherited by another class. Okay, this is called multi-level inheritance. So I'm going to put a comment here. Okay. Hybrid inheritance, as the name suggests, it's a combination of multiple inheritance types. Different inheritance types, let me say like that. So if you're trying to, let's say, do multi-level, and if you're trying to do single inheritance or combination of like these different inheritance types, it's called hybrid inheritance. Okay. Now let's look at, this is multi-level we have already seen. We have already seen single level. Now there is one more thing called multiple inheritance in Java, but it is supported by only interfaces. By interfaces, not by classes. Not by classes. So we are going to look at that in action. Okay. So now let's try to create a multiple inheritance interface using Java. If it is possible by class, let's have a look. Okay. So instead of saying multiple inheritance, let me also say if it can extend one more class called subclass. So we are now trying to say it extends multiple classes. Okay. Syntax error, insert class body to complete class declaration. Okay, let's see if we have missed out any brace. Okay, so it's not supporting multiple inheritance. We are getting some error. Let's do one thing. Let's for now remove it from here. And let me try to add this here. This is also multiple inheritance, right? So what is it saying? It says insert this block to complete the class. Okay, let's have a look. Okay. I think there is some problem with the bracing part. Just a minute. So yeah, basically this is not allowed. Okay, it's see our scope is correct. Okay, its scope is correct. It's not allowing us to do multiple inheritance, as I had mentioned, because we are not supporting multiple inheritance in Java. Okay, so that is the reason why we have to use interfaces to solve this problem. Okay, now how does interface play a role here? What we are going to do is we are going to have a class implement multiple interfaces. So let's do that. So where is the interface which we had defined? We had defined the interface here, class object functions, right? Here is where we have created our interface. So what we will do is we are going to create one more interface, and let's call it as interface usable one. And here I'm going to have some other abstract method. So that's not compulsory to have always the variables. You can have just the methods as well. So here I'll say get info. Okay. So now if I try to implement multiple interfaces in Java, this is allowed. Okay. But now it will have to implement the get info. So add unimplemented method. So then we have to implement the get info. And if you can see here, we are getting this kind of a annotation called override. It means it has overridden the method which we had got from the interface. So this is how we will be able to do multiple inheritance in Java with the help of interfaces. Okay. So this is a very important concept, and it is also very important to be aware of this in the interview. Now comes the important part. Let's say if you are implementing multiple interfaces, okay, but you are not able to give definition for your one of the method or one of the interface, what will happen, right? Let's say if I comment out this particular piece of code, what will happen? It is going to make you make this class abstract. See here, this is a second suggestion given by the compiler. Either you make this as an abstract class or you have to add the unimplemented methods. Abstract means a class having at least one abstract method. Like this is an abstract method now, right? Get info, which is coming from this interface. So if you don't give a definition for this interface, this class we will have to write as an abstract class. You'll have to call it like an abstract class, like this. Then this error will go away. But we don't want a class to become abstract. So we can remove it for now, and we can also give a definition. This is just for your understanding. I give an idea about it. Okay. So this is all about interfaces. This is all about inheritance, which we saw. Now let's come to the very important topic of exception handling in Java. So for that, I have a diagram which I have created to explain to you all, right? So what is exception handling first of all, right? And what are exceptions in Java? So exceptions is a very important topic, and any programming language, there is a way of how we can handle exception. But what exactly is exception? Exception is something like an abnormal condition which happens during our program execution. It could be due to some logical errors in our code. It could be due to runtime. There is some problem with the machine. Okay, I mean to say with respect to the memory or some other kind of errors. If you see this diagram, for example, there could be something like there is wrong with the memory, right? It is full, memory is full. We can get out of memory error. It could be the case that we are storing data into some stack, right? Or some heap memory. It could be also the case that we have some stack overflow error or some virtual machine error. So these are some runtime machine specific errors can also happen. But there are other types of exceptions also which can happen. And those exceptions, we make them categorized under the parent category as exceptions. Okay. And any abnormal errors which happens due to machine specific thing, we are subclassing it under the errors category. So overall, everything in Java is an object. Okay. So the child of object is throwable. So this is the parent object of the exceptions. Okay. If you see here, this is the parent object of exceptions, a parent of this exceptions. So under exceptions, we have two types. We can have checked exception or we can have unchecked exceptions. Okay. And the second category of the issue which can happen inside throwable are errors. And errors are of these different types. Okay. And under exceptions, you are having two types. You have checked exceptions, or also called static exceptions, or also called compile time exceptions. And the next category is called unchecked exceptions or runtime or dynamic exceptions. Okay. What are checked exceptions? These exceptions are generally caught at compile time. Means when you're doing the coding and when you're trying to write certain thing which is not correct or invalid, you would be able to get this kind of a checked exception because it will be identified by the compiler at the compile time. And there are three categories of compile time exceptions. One is input output exception, which we make it called as a IO exception. We have SQL exception. In case if you try to execute some SQL query, and there could be a chance that you may get some database not connected or some different types of SQL connection error. Let's say the query is not right. The SQL query which you're trying to execute is not correct format. So you may get a SQL exception error. Then you're trying to identify, or you're trying to access a particular class, but you're not able to get that class. So you're going to get a class not found exception error. Then there are some exceptions which are caught at runtime. Those are called unchecked exceptions. We have different categories of unchecked exceptions, like there is arithmetic exception, then there is null point exception, then there is number format exception, then we have index out of bounds exception, like we have array index out of bounds, then we have string index out of bounds. So we are going to look at these things in practical, so do not worry about that. So I'll just show you all what happens in real time and why exception handling is required. So let's get on to the exception handling part. So we will create a separate class here and we call it as exception handling. Yep. So as we had promised, we are going to look at all the concepts in Java from A to Z for you to be very much efficient in core Java. And this is going to be covered in 1.5 hours. So this is the second part of my video. Okay. So second part is the advanced part. That's why I had kept it in the second thing. Okay. Now let's do one thing. Let's create a method and let's say public void and let's say arithmetic calculations. Okay. And let's have the user input to this particular method some value. Let's say number. So I can make it static as well. That's fine. If in case it is static, I don't have to create an object of the method. I can directly pass this method name in the main method. Okay. So let me write like this. Let me say 10. Okay. So this is very simple code which I'm writing here so that anyone can understand. We are going to call this method arithmetic calculations, and we are going to do some calculations inside this method. And we are going to take a number from the user. So user is passing 10 here from the main method. So what I'm going to do is I'm going to create one variable called result equal to 0. I'm going to initialize it to 0. Then let's say I want to print this value result. So I'm going to basically yeah, let's do one thing. Let's say result which we have. Okay. So we are going to do this particular number divided by result. Okay. We want to find out what is the output of dividing our number with this particular result variable. But make a note, result is having value 0. Okay. So you're trying to basically divide some number by 0. So you are going to get an exception in Java. So let's see what happens in this scenario. And after that, there is some code which I want to perform. Here are next set of calculations. Let's say, let's do some calculations beneath this line. And let's say result equal to result plus number. Let's say here we were trying to do division. Here we're trying to do addition. And I want to print the addition value. So I'm just trying to have some code here. Result after addition with number is okay. So I'm just trying to put that value here. Let's run this program. So I'm going to clear this output and I'm going to run our exception handling demo. So we are getting an exception here, and this is what I meant an exception in Java. That something logically might be wrong, something could be wrong at the runtime at the machine specific level. So here our logically something was wrong. So we are getting a divide by zero exception error. You can see we are getting an error, and the category of the error is arithmetic exception. And if you look at my diagram, arithmetic exception is one of the exception under the unchecked exceptions. Okay. So this is the first category of exception which we have looked at, but which is caught at the runtime. It is called as a unchecked exception in Java. Okay. And due to this, what happened? You can see that line number 10, 11, and 12 were not executed. Abruptly, our program execution got stopped at this particular line, which is not a correct behavior. Always in any programming language, our framework should be designed in such a manner that irrespective of any kind of error which happens, we have a way of handling the error and our execution should continue further. It should not stop abruptly like this. Of course, we should get a stack trace or get a log as to where exactly and what exactly went wrong, but we don't want to stop our execution in between, right? So for that, what we will have to do is we will have to handle this exception. So what we have to do is we have to handle the exception through different ways. So there are different ways of doing exception handling in Java. The first and the most important is the try catch. We can put this entire code into try block and put a exception here. So we know the category is arithmetic exception, right? So let's catch here. Let's write this particular thing here. Arithmetic. So this is the class name. And then we can write this out. Exception pod in method name. This is how we need to write as per naming convention. It should be known as exactly where the exception is coming from. And take the object E and then use get message. And you can also print the stack trace. There is another method. You can also print the stack trace. So you can see get stack trace. We have another method here. Okay. So this is the way how we can handle the exception. This is the first way, okay, using try catch. Then there is another way. You can also put finally block, okay, and finally block means we will be handling whatever closing of connections are there, closing of objects basically, like cleanup. I can say closing of objects or DB connections or any other cleanup we will be doing inside the finally method. The reason is sometimes after we are even catching the exception, we are just ignoring that there are some objects which have been already used. There could be some file connection could be open. There could be some database connection open. So we don't want to simply leak the memory being utilized once it is kept open. Even though our execution is over because we got an error, we want to close some objects after its execution is completed, be it positive or a negative scenario. We have to always have a finally block. It's not compulsory, but it is a good practice to have a finally block with the cleanup code. Okay. And we can also have just try finally. I'm just explaining you all functionally. If in case you want to skip catch, you can also have just try and finally block. And another thing is you can have this try finally. This you can also have nested try catch. So what I meant is that let's say I want to have a try block outside. Okay. I have handled the inner thing carefully, and I can have a block outside like try finally. This is also allowed in Java. You can have nested try catch blocks. Okay. So within a try block, I can have a another try block, but then the important part is you need to match try with catch or with finally. Okay. You cannot simply leave try. Like example, if I try to skip this part, catch and finally for the inner try block, it is going to throw me error. You can see here that it says you have to insert finally to complete the block statement. So this is mandatory. You need to have at least finally or catch within your try block. Okay. So for now, I'm removing the outer try. I just wanted to explain this is also possible. So this is the first way is to use try catch. Okay. Second way is try finally. These are different variations of doing exception handling. Third way is to use try catch finally. Means all the three blocks we are using. Okay, and now we are going to look at the fourth way, which is to use throw clause. We are going to comment out all these things, but these are the different ways of doing exception handling in Java. So fourth way is to use throw clause. Means I can explicitly have, so this is the first method. Let's not touch this method. Let's create a separate one. Okay. Extra pieces. Let's create another one and let's say method 2. Method 2. Now what I'm going to do inside this method is I'm going to say throw new arithmetic exception. So rather than using try catch, I can simply delay the exception handling. Okay. And now let me say this as static as well. Let me directly call this method 2. Okay. Now let me run this program. But for now, I'm just going to comment out the first ones because we've already looked at try catch handling. Now let's look at the throw new, how it works. Okay. So we can also run like this way and say Java application. And now you can look at the stack trace. Where are we getting the error from? We're getting at line number 41. If you click on it, it is going to take your cursor to that. Then what is the next stack trace? It is because we are getting the error thrown from the line number 36 inside the method 2. So what has happened is you have simply postponed the exception handling at runtime by using throw clause, right? But is the main method handling the exception, right? Is it taking care of the exception here, which is thrown at this method too? No, right? So either you have to do try catch here, or you need to do try catch inside the main method, inside the method too. So I'm doing try catch now. Okay. Arithmetic exception. And I'm going to say error for exception for. I'm handling the exception now at the main method level. So now if you run this code and let's say you have certain piece of code here, main execution done, what is going to happen? Let's say we have this code now. We also have written some code here. And let's say method to execution done. Let me show you without this code, what would have happened? Without this try catch, if I simply had written only method call, what would have happened? So for now, I'm going to do commenting this part. Okay. So let's see what is happening. So you can see here, this is the code not reachable exception because we are throwing it runtime. So this is not possible because compiler will stop us from doing it. So this is fine. Let's run it and see if this line is getting printed or not. Okay. You can see here, this line is not getting printed. Okay. And why did we get an error here? Because we are forcing the compiler, we are actually throwing a exception at the compile time itself. We are forcibly throwing an exception. So compiler understand it's an exception. So it will basically understand that this is not going to go anywhere. It is intelligent enough, our JVM, that this is not going to be reached. So that is why it is throwing us an error at compile time that you need to remove this code because it is unreachable. Okay. You can see here the message is unreachable. So that's why I removed this code. And this line did not get printed because we got an exception here at runtime. So what do? We can basically do it by commenting out this now line and trying to uncomment our try catch block. And now this exception being thrown will be caught by your main method because we have used try catch mechanism. And even this line also will get executed. Let's run it and see. We can see that we have handled the exception. We have called method 2. We have handled the exception which was thrown. We have also got this line of code getting executed, which is after the try catch. So this is the beauty of exception handling. It is definitely helping us to go ahead with our program execution. Okay. So this was the fourth strategy using throw. Now another way is using throws clause. So what is throws clause? Throws clause is also like postponing the exception handling. So what we are doing is here we are throwing arithmetic exception, right? We can write like this. Throws arithmetic exception. Okay. So even if I don't write this, if I write some piece of code, hello, method to execution, right? Still, okay. Still we can throw arithmetic exception at the method declaration level. Okay, this is also fine, or this is also okay. You can write this line, then you can have this particular line coming after this is out, and you can also throw this arithmetic exception. But there is one catch here. Let's say I'm trying to throw multiple exception. I can also throw multiple exception, right? So you have shown here throws arithmetic exception. But what if I want to handle multiple exceptions? Like I want to also say null pointer exception. Can we do that? Right? Is it allowed? You can see it's not allowed, right? You cannot throw multiple exceptions. So what we'll have to do is we can still do this way, and you can remove this comma. So what is happening now? We are able to throw multiple exceptions using throws clause, because throws will allow you multiple exceptions provided the name of the exception is correct, and you should be handling both the exceptions now at the runtime. But using throw, you can handle only, or you can throw only one exception. Only one exception can be thrown using throw. Throw new. Okay. But multiple can be thrown using throws. This is an important concept to keep in mind if you're preparing for any Java competitive exams online, like for certification or for interviews. These all different concepts are very important. And another very important concept is how do you handle exceptions when there are multiple like this, right? So let's catch multiple exceptions now. Now that we are calling method M2, let's also catch. Okay, let's for now run it without handling it and see what is the output. We are throwing two exceptions, remember, but we are handling only one arithmetic. Okay, still we are saying exception caught. Okay, because we got arithmetic exception caught. Okay, now let's just change this particular one. Let's do one thing. Let's call method 3. Let's call method 3, and in method 3 we will be trying to have certain exception thrown. It's static void method 3. Now inside method 3, I'm, let's say, going to throw null pointer exception. So this is why this concept is important. Why am I saying multiple exceptions are important concept we use in throws? Because you can have a scenario where there are multiple exceptions thrown. For example, see here. Here in method 2, we are throwing one exception arithmetic. Here I can show by throwing null pointer exception. So what's happening here? Your method 3 is throwing one exception, but your method 2 is calling method 3. Okay. It's unreachable code, of course. Yeah. You need to put it here. Now it is not unreachable. Now it is reachable, right? Because compiler doesn't know what is happening inside method 3 until it tries to run it at runtime, right? And then you're trying to throw arithmetic exception. So now you have got two exceptions being thrown. Method 3 will throw you null pointer. Method 2 is going to throw you arithmetic. So that is why we need to have a way of handling. That's why throws allows multiple exceptions. Now, when we are calling it inside main method, we are handling only arithmetic here. Okay, let's run it. You can see that we did not handle the null pointer exception. That is why we got an exception at the runtime at line number 51. And then inside it, internally, it is taking us to this line number 39, where we got the null pointer. So we need to still handle null pointer. That is what the understanding we got, right? So let's handle null pointer by putting a catch clause here. And let's try to close this out. And we can write here the respective category, arithmetic exception caught, and this is null pointer exception which we have got. Okay, so this is an exception handling in detail I've explained you all. Now, if you run this program, what is going to happen? It is going to handle it. Let's run it. So we can see we have got all the execution captured. Now, one more important thing is that we can also have the parent object also added, but important thing is we should not add the parent object first. It should be added after the child exceptions. So if I write, for example, exception caught, okay, this is not allowed in Java because these are child exceptions which will be caught by exception. So if you mouse over here, it says unreachable because it is already handled by the catch block. So you need to always sequence it in such a way that child is followed by the parent exception category. And that is all what we have from an exception handling perspective. So let's run this piece of code now and let's see what is the output. So here we go, and we have completed the exception handling. So this is just a way that I have explained you all the hierarchy as well as I've explained you all how to do exception handling. And like that, so many different types of exceptions can be there. So we have seen so far arithmetic null pointer, but there are so many other types of exceptions which can be there. So you can look at my video in Java exception handling in my Java playlist to have a detailed understanding about exception handling for the other types of exceptions. So let's go ahead with our Java course. So here we are with our syllabus, right? We have covered majority concepts here, right? Now let's look at a very important concept of JDK and JVM. Okay. So what I'll be doing is I just want to ensure you all are understanding this concept because from an interview perspective, this is also critical for you to be aware of. It's a conceptual thing, but it's important to know. So just a minute. Let's open Paint. Let's have a small block diagram. So this is like your JRE, which is a runtime environment. Okay. And inside JRE, you will have JDK. Okay. So JDK is here, and here is where your development kit is present. So you will be having all sort of tools like Java, C, and whatever things you require for compiling or running your program. Everything will be part of your JDK. Okay, JRE gives you runtime support, like whatever different libraries are required and different support is needed. Your runtime environment is going to give you support using different libraries for your program execution. This particular thing you need to keep in mind. JDK is within our JRE, within our runtime environment. Okay, let's continue further. We have looked at comments, we've looked at access modifier, variables, data types, control statements, operators. We have looked at all the different keywords. We have seen how the path and class path is set up. We have, of course, seen the intro for Java. Then we have looked at object-oriented programming principles like object, class, methods. We have looked at method overriding. I will cover method overloading now. We have looked at inheritance, all different types. We have also looked at abstraction and interfaces and encapsulation, constructors, and exception handling. So only two things are remaining in our today's video, that is collections in Java, and we are also going to look at the method overloading. Okay, so let's cover the method overloading part. Now, what is method overloading in Java? Let's say there are different methods which are present. Okay, let's say, for example, yeah, I have set roll number. Okay. Now, instead of set roll number having only one attribute, I can also have two attributes, and let's say string name. Okay. So what is happening? I have the same method signature in the sense that the return type is same, right? And the access modifier is also same. Name of the method is also same, but the number of parameters are differing. Name of the method is exactly same. So this is an example of method overloading. Means at runtime, the compiler will decide whom to call, to this method or to this method. Let's call this method now using set roll number from our runtime. So let's say for obj1, so let's say for stud, for example, let's do one thing. Let's say stud dot set roll number. Okay. This is saying roll number is 10. Okay. Let's see what is getting assigned to this object. And let's say this is saying this is for John. Okay. And let's change the value to 12. And now when I do get details method, if I look at the implementation of get details, what is get details going to give me? It is going to give me name. Let's also get the roll number. And let's see what roll number is getting assigned, right? So I'm just going to say this dot roll number. Okay. And roll number can be accessible because even though it's a protected field and we are trying to access in the same class, it's not a private field anyway. Or you can also use the getter method. But this dot roll number is also fine. See, we also have a method for get roll number. So both are okay. Let's use get roll number method. That's also fine because we have already defined the method to use it, right? And get roll number is within this class, so we can just say this dot get roll number. Okay, this is how we are doing it. Now let's run it and see what happens at runtime. Okay, let's look at the roll number assigned for John. It is saying 12. It is not using the value 10 because it has called the method two times, but different methods have been called. So first time when it used only one parameter, that is integer, it was calling this method. Okay, this is an example of method overloading. But when it called this method for the second instance, that is this one, it is using the second definition and it is passing the string John to that. And that is why the roll number is assigned with whatever value you're passing in this particular method. I hope this considers and how the method overloading takes place. So this is an example of method overloading. Method overloading. So we have covered method overloading, method overriding, encapsulation, inheritance, interfaces, abstraction using abstract classes. So yeah, we can also have an abstract class. So let me show you that as well. So let's say class 3, for example. I'm having abstract. This is how we create an abstract method. Abstract void method 5. This is how an abstract class is created. If you see, it is saying you have to make a class as an abstract, or you need to give a definition for the method 5. So let's make the class as an abstract. So this is an example of an abstract class. Okay. Now, this is basically going to give us 0 to 100 percentage abstraction. It's not going to give us always 100 percentage abstraction. But in interfaces, we are going to get 100 percentage abstraction because everything is abstract in interface. Okay. So for example, I can also have a method here like public void method 6 with some definition. So that is why not necessarily abstract class means that all the methods have to be abstract. At least if one of the method is abstract, then that class we are going to call it as an abstract class. Okay. So this is the way how we achieve abstraction using abstract classes and using interfaces, which gives us the 100% abstraction. So interfaces before Java 1.8 gives us 100% abstraction, because in Java 1.8 we have some way we can give some definition for methods also, like default methods inside the interface. So we will look at that in our separate video. So this is important for you to understand that before Java 1.8, this is how interface used to give us 100% abstraction, and abstract classes can give you 0 to 100% abstraction. Now let's look at the last concept in our today's 1.5 tutorial of Java, that is collections in Java. Very, very important topic and very important in terms of interview as well. So let's get on to collections in Java. So I have got a separate hierarchy diagram for collections in Java. Let me open that one, which is this hierarchy. Okay. So we have a parent object called iterable, and we have a collection which is a child of iterable. And inside collection, we have got three interfaces now. Okay. So you can look at this arrow mark. This solid represents implements, and this arrow represents extends. So collection extends iterable, list, queue, and set are the interfaces extending collection interface. Okay, all these five are interfaces actually. So if you see here that we have got different classes like array list, linked list, vector. These are implementing the list interface. We have got priority queue class, which is implementing queue. We have got DQ and array DQ. Okay, so DQ extends queue. Okay, DQ basically means that we can add and remove from both the ends of the queue. Okay. And then we have set. Okay, so in set we have got different types of sets. We can have got linked hash set, which is implementing the set interface. We have got hash set. We have got linked hash set, right? And we have got sorted set, which extends the set interface, and tree set is implementing the sorted set interface. Okay, and we will look at map interface also, that we have got sorted map class, which is implementing the map interface. Okay. And we have got tree map implementing the sorted map interface. Okay, now in hash map we have got a separate class called hash map. That hash map extends the map, implements the map interface here. And we have got a class called linked hash map, which is like a variety of hash map, which is extending the hash map. So we look at all these things in our tutorial session today. But let's just look at an example. So let's go directly onto the coding part. Let's have a separate package actually, because collections, I want to keep it as a separate one. Yeah, or we have already a class defined. That's okay. We can go inside this one. Okay. So first thing is, if you want to create an object of a list interface, let's say we have got array list. If you look at the diagram, right, we have got an array list class, right? Array list is a class which is implementing the list interface. So let's look at how do we create an array list. So we can create an object called array list obj equal to new array list. So this is how we need to create an object of a array list class. So if you see, we have got this as a part of Java util library. Import that, and also we need to import this particular class. So do mouse over. Yeah, and you can see here you have to import array list from java.util library. You can also basically write util.star. So that way everything gets imported. So this will be like redundant, right? So if you see, everything gets imported. So this is one way. Now, what are the different ways of methods which are there inside array list, and what exactly is array list? I'll let you all know. So this is like an array, okay, like how we have seen. There is also concept of arrays in Java, by the way. Okay, let me first explain the normal static array. This is like a static array, means its size is fixed. Once you create a static array in Java, its size is fixed. So let's look at the array concept now. Then we'll come to array list. Okay. So let's say, for example, I have an array here, ARR, which is going to have a value like 1, 6, 10. So like that, I'm going to have an array. Okay. Let's have an array like this created. And let's try to find out the length of the array. How do we get the length of the array? We have a separate method actually called dot length. Okay. And if you want to print the value of the array, what you can do, you can write a loop I equal to 0, I less than ARR dot length I plus plus. Okay. And I just want to simply access the value of ARR of I. This is how we are going to get all the values of the array elements separated by space. We are going to use a for loop to do iteration. This is for single dimensional array, by the way. It is one dimensional array. Like that, we can also have an array 2. Okay, I'm just explaining the array concept here. So array two-dimensional array, we need to use like this two rectangular bracket, and there is going to be like this. Okay, means we will be having rows and columns here for two-dimensional array. So I can have 2, 4. Let's say this particular one has 5, 6. So basically, what I mean here is that I have two rows of data, and there are two columns. First column is having value 2. Second column is having value 4. Likewise, second row, first column is having value 5, and second column is having value 6. Okay, so in that case you will need to have a two-dimensional array, but always if you see here, the length of the array is fixed, right? So here you need to have a separate iteration for getting rows and columns. So j less than ARR of I dot length, because we want to find the length of the columns. Okay, so it's going to be ARR of 2, because we are using array 2, right? Array 2 is a two-dimensional array. So you need to say array 2 of I dot length. So this is going to give you the number of columns, and we need to use this way to print. So this is going to be static in size. We can't change the value, a size of this array. It's going to be fixed of having 3 numbers of array. Likewise, the two-dimensional array is also going to have only 2 types of data, like 2 rows of data. I can't change the number of rows or columns once I have defined here. That is the problem with static array. So anyways, let's run this execution. Let's run this program and see the execution output for getting more understanding. Okay. We have got the value printed. Okay, let's have a look what went wrong here. Second one, system.out.println add. Okay, sorry, I have not printed J. Okay, so we have to give the two-dimensional indexes I and J both. Now let's run it. And what I'll be doing is for separating of the data, like after every execution of the row is over, let me write system.out.println for the next row. Now let's run the program. So now you can see that we have got the output 2456. After one line of code is printed, we have got a new line character here, and then only we are printing 5 and 6. But for the one-dimensional array, we got all the output in a separate line. So if you don't want to print in a separate line, we can remove this ln and you can instead separate by space. So let's try once more. So this is a two-dimensional array and one-dimensional array we have seen. Yeah, we can look at the output now. And yeah, by the way, I can actually write this way. I can give this way and now run it again for it to look correct. See, 1, 6, 10, 2, 4, 5, 6. This is a two static array. Okay. What does array list give here? Here it basically allows us to increase the size of an array. It's called a dynamic array. We can increase the size as well as decrease the size. And it also works on the basis of indexing. Like for example, if I had to access a particular array, always the array element starts from 0, then 1 and 2 indexes. These are the indexes in an array. So if there are three elements, this is the zeroth index, which is having value 1. First index is having value 6. And second index is having value 10. This is how we talk about in static array. So let's have a look as to how this array list is going to work, right? So you can add the elements basically by using dot operator, and we can add an object here. So let's say I'm adding value 10. Okay. Then I can also use it to add another value. Let's say I'm using it to add another value, let's say 20. And let's say I'm going to add another value for 30. Now what happens is that these all elements are added. Now if you want to just find out what is the output for this, so you can basically go for a iterator object. So there is a iterator concept in Java. So what I'll be doing is I'll be using this one and I'll say iterator. Okay. So this is just an overview. If you want to have a detailed conceptual understanding of all the concepts of collections, I'll create a separate video for the same. So for now, I'm just showing one example how to iterate the values in case of an array list. Okay. So here, what is the type? There is no type defined. If you see, the list is of not having of any particular type. But if you want to define a type, you can still define like this way. So these are called generics in Java. So I'm going to have a generic example also given so that it is clear. So in this case, we need to create a generic type because we have given our array list of this type. So iterator of integer, and I'll say array list iterator equal to this one, right? And then we need to write a loop here that till this has next values, has next, right? We are going to start getting each value one by one. So we are going to get this dot next, store it into an integer. If you see the output here is return type is integer. So integer int val equal to store this value, and then you can print it. So directly you can print it and you can give space. So I'm just giving an example of main classes one by one, and then that's all we will be covering in this video, but we can have a separate video for detailed collections. You can see that we have got 10, 20, and 30 because we have separated by space. Yeah, I need to remove this new line. Let's run it one more time. Yeah, 10, 20, and 30 are separated by space. Likewise, we can also have another collection which is based on map. So basically, we have one more collection called hash map. This allows us to store values in the form of key value pairs combination. So I've got a separate video on collections in Java, and you can look at that and leave a link for the same in my video. So how do you create a hash map? You have to create, again, you can go for map also. Map hash map hash be equal to new hash map. So in case of hash map, you need to have key value pair. Okay. So you can have a hash map like this, string comma integer. Okay, you can create a hash map like this, and you can also give this type on the left hand side. Now for hash map, the way we add the values are a bit different, and it uses hashing mechanism so that we can retrieve the value in a faster way. So you can add the hash map values in a hash map by using put command. Okay. So we need to give a key which is in string format. Let's say Srini is having some roll number, for example, let's say 10. Okay. 30. Let's just say we have two values. Okay. Now, if I want to print hash map, let me show one thing here. We don't have iterator supported for hash map like the way we had for array list, right? So if you try to do this way, hash mp dot, you don't see any iterator. See, there is no iterator object. If I do dot, there is no iterator object here. So you have to basically convert it into a entry set. So you have something called entry set. Okay. So you have to first convert it into an entry set, and you can see the output is a set. So we look at set now. So entry set, which is of type entry, string, and integer. Okay. So if you just do mouse over, this is set of entry. So you have to create an object like that, set of entry, and the entry has to be of type string and integer. And let's say set entries like this. Okay. We'll have to import this from the Java util map. Okay. So this is what we need to do in case we want to iterate it, but it is not done yet. Now let's look at how we can iterate over a set. Okay. So I'll complete the hash map first. So as I told, hash map is going to store your data into key value pair combination, and you need to get a value for a key. So like that, we can have keys like Srini. So you can try to access the value for key Srini by using some method, and it will return you the value 10. So it uses the hashing mechanism to do it in a faster way. Okay. But since iteration is not supported in hash map, we had to use set, entry set. So now here we will use this iterator method. So we will have to use iterator method on this set entries. So we will say set entries dot iterator. Okay. And let's put semicolon. Again, do a mouse over, and you can see it's an iterator of the same type. So I need to write here on the left hand side, iterator, and put this type into bracket. Okay. And I'm going to say ITR entries. Right. Now let's try to iterate over this object. So again, the same concept is going to be there. You need to use ITR entries dot as next. Okay. This is how we will iterate the value. Again, get the value one by one. So I'm going to say dot next. What is the value retrieved? We will retrieve one entry. See, it's a set of entry. So we'll retrieve one entry, right? So just copy this internal part to create an object. Let's call it as entry. These were entries, is an entry. Now, in order to get a value of a key and value pair, we need to write entry dot get key. Let's give some arrow here, and let's say entry dot get value. So this is how we will be able to retrieve a key and value pair for all the values inside a hash map. Now let's try to run this program. So this is going to give us a complete understanding of how hash map we can add the value, run it in a loop fashion to get the values. You can look at here the output, right? Srini 10 and Sandeep 10, Sandeep 30, right? So this is the output of this particular program, right? So we have got the arrays checked, right? We have also seen how the dynamic array works using array list. We have seen how the hash map works using the basis of key and value pair combination. Now, since we looked at set iteration, let's look at what is set. Set basically stores only unique values. So whenever you have a requirement that you need to store only unique value, set is the right data structure to use in Java. So for example, let's say set, you can give any type for generics. So let's say set vals equal to, I can say 20, 40, 30. Again, let's give 20, for example. And now let's say set vals dot size. So how much do you think would be the size of this particular set? Use curly brace, sorry for that. We need to use curly brace, not rectangle. So what do you think is going to be? Yeah, just a minute. I think we need to, it's not an array, right? So we need to use proper way of doing it. So let's look at the diagram and let's see what particular set we can go for. Okay, we have hash set, we have linked hash set. There are different types of sets which we have. So we have tree set as well. So let's say we want to go for, let's say, yeah, hash set as an example. Let's go for hash set. So hash set will be having some hashing mechanism used. So let's say we are trying to have a hash set of integer. Okay, we are defining a hash set, and in this set values, I can also add the values using add method. Right? Let's say 20. Let's say 40. Let's say 20 again. Now the size of this particular hash set is going to give you 2, not 3, because 20 is duplicate. It's not going to store 20 again. So let's look at that. You can see the length is 2. This is the important concept to remember in set. In case of array list, you need to remember that it will always, array list always stores in the same order, stores data in same order. So it maintains iteration order. So for example, if I try to say sys out array list of obj, if I want to, let's say, get the some object, so I can give the index starting from the first index, 0th index. So I can give 0. Okay. Like that, I can try to give for 1 also, and you can see what is the output for all these 2 indexes, 3 indexes. So it's going to give 10, 20, 30 in the same order because it maintains the insertion order, maintains insertion order, right? Array hash map doesn't maintain the insertion order, but it stores the value into key value pairs. It doesn't maintain insertion order. Okay. And set, we have said it stores only unique values. So we have looked at 3 data types. Let me run this program. And you can see here we have got 10, 20, 30 printed in the same sequence, right? So far what we have seen is this one. Yeah, so far what we have seen is we have seen hash map, right? We have seen hash set and we have seen array list. So it will take a lot of time for me to create a detailed video. So if you would want me to create detailed video for every type of collection, I'll definitely do that. But let me explain you now functionally few more things, right? So you have also got queue. So queue is basically like that you can try to add the elements into the data structure, and whichever element is coming first, it will be coming out of the queue. It's like a first in first out we call, right? First in first out we call for a queue. Then we have something called stack. If you see here, stack is implementing vector. Okay, so vector is basically like it's not used in much use in the Java collections anymore, so we are using stack still. Stack basically works on the principle of last in, first out. So whichever is the last element to be inserted will be the first one to be taken out. Okay. Then we have hash set. Okay. Hash set we have already seen in operation, but it uses the hashing mechanism to store the data. Linked hash set will also store the insertion order. Okay. So that is the thing about linked hash set. Sorted set will be able to sort the set as per ascending order, or we can also make it store into descending order. Okay. And tree set is like a primary thing which is used if you want to basically maintain the insertion order. We can go for tree set. It will basically implement the sorted set interface and it will be maintaining the ascending or the descending order as per our logic. Likewise, tree map is also going to maintain the ascending or descending order because it implements the sorted map interface. And linked hash map is going to maintain the insertion order for your entries in hash map. So whatever entries we saw, right, this is going to be maintained. So let's try to do one thing. So in this case, we had only two data. What if I had multiple data? Then you would come to know that whether it is able to maintain insertion order or not. Let's say we are giving some more values. Okay, let's run it and see whether we are getting the same order returned. You can look at the output now. We are getting Srini, then Vijay, then Ajay, sorry, then Sandeep, then Ajay. It's not maintaining the insertion order. But if you want to maintain the insertion order, we have to go for linked hash map. And if you want to get the ascending and descending as per the key or the value, then you need to go for tree map. So tree map basically gives you for the key. If you want to get your data in a ascending order of the key, let's say Ajay should be printed first, then your Srini, Sanjay, Srini, Sandeep, and Vijay. Then you need to go for tree map. So let me show you tree map example as well, and we'll stop here for our Java overview in a couple of hours. So let's create one more particular tree map object, right? We'll say tree map here. So I'm just saying tree map, okay? And this is going to be object of tree map, okay? And here we are going to have the same data inserted, okay? And now you'll see the difference between the two as to what exactly happens in case of tree map. We are putting Srini, Sandeep, Ajay, Vijay, okay? So now we are going to print it, right? So for printing purpose, what we'll have to do is we'll have to run this iteration loop again, but this time it will be with your tree map, okay? So tree map, we have to use the object here, okay? And we have to basically convert it into a tree map entry set. So we'll have to give another object name here. And yeah, this entry is one, and yeah, this is fine, okay? So this is going to help us to print the tree map values. So let's try to print tree map, okay? And let's run the program now. So this is for tree map, and the before that one is for hash map. Let's run it and see what is the output. Yeah, so after tree map, if you see, we are getting Srini, Vijay, Sandeep, and Ajay. Okay. So basically, we are not able to get the insertion order maintained. So let's try to see what is went wrong here. Yeah, so we had done a small mistake here when we were doing copy paste. We forgot that. So if you see here, TRE map is used correctly, but we are using a set entry. So it should set entry is one. Okay, that is why we did not see the sorting happening. And we can also leave a line because it would give a good way of separating the old and the new value. So this is how you can give a new line character. And now let's run the program and see. Yeah, so you can see here after tree map, we have got Ajay, Sandeep, Srini, and Vijay, which is in a proper sorted fashion based on the key. So this is the beauty of tree map, and so many different data structures have got different significance. When to use what is so important to know, especially in terms of using it for your projects in automation frameworks or for development or for during interviews or any competitive exams of Java. This all concepts are so critical. So I'll definitely create one detailed video for all the collections in Java. It could be like in couple of parts, but I'll cover all of the different classes with examples. I hope this video was clear and you were able to learn Java in just a couple of hours. Do like my video and subscribe to my channel if you have not done yet, and please do share with your friends. Thank you so much, guys.